In this video, we'll see how we can use the PPA optimization tab on the interconnect architect to specify traffic parameters. This traffic profile information is used by the interconnect architect to generate a microarchitecture that meets your performance needs. Under the PPA optimization tab, in the traffic pane, use traffic parameters is enabled. This allows you to specify basic and advanced traffic profiles. Under the Basic Traffic tab, in the Traffic Profile Editor pane, there are two additional traffic profiles, one read profile and one write profile. For both the profiles, the peak and average bandwidth is set to 32 gigabits per second or 32768 megabits per second. These numbers are purely for demonstration purposes. For best results, we recommend specifying peak and average bandwidth that can accurately represent your network traffic. Do not specify your peak traffic requirements as your average traffic requirements, as it could lead to NoC-SE oversizing your configuration. The Traffic Matrix Editor pane specifies the read and write profiles assigned to each path. Under the Advanced Traffic tab, in the Traffic Path Scenarios pane, there are three path scenarios. The first traffic path scenario specifies 50% reads and 50% writes from S0 to M0. Similar traffic path scenarios are specified for S1 to M1 and S3 to M1. In the Traffic Use Cases pane, there is one use case that includes these three traffic path scenarios. In the canvas, NoC-SE is used to auto-generate the microarchitecture. NoC-SE uses the traffic specification to generate a topology that meets your performance needs. Based on the performance needs, the ASNIs and AMNIs are configured to be high wire, and HSNI, HMNI, and PMNIs are low wire. Now, let's take a look at the area report. The total area for this configuration is 38587 or 38,587. Now, let's run the same performance test case on this configuration. On running the same test case, the read bandwidth on each ASNI is 5,333 megabytes per second. This is roughly around 42 gigabits per second. The write bandwidth on each SE is 4000 megabytes per second, which is roughly around 32 gigabits per second. So, we see a significant performance improvement over the reference configuration. Feeding in accurate traffic requirements helps Interconnect Architect to auto-generate a topology that meets your traffic needs. For the best results, we recommend that you give as much detail as possible about the different traffic types that are expected on each path and the different traffic patterns that are expected on the interconnect. The area count of this configuration is higher than the reference design. The upcoming videos will focus on how to refine this configuration to optimize for area without any compromise on the performance. The upcoming videos will provide guidance on selecting and modifying configuration parameters in this NI tower configuration to maximize the performance to area trade-off.